Here are the answers for the day 2 warm-up. Question A, find the mass of this amount of moles of iron oxide. This is a dimensional analysis problem where we'll write down the given amount of moles and then multiply by a conversion factor to change into grams. On the bottom, 1 mole of iron oxide. On the top, a certain amount of grams of iron oxide. We just need to figure out what number to put on the top of that conversion factor. Well, how many grams are in 1 mole of iron oxide? That's the concept called molar mass, which we've worked on previously. Using a periodic table, you can find the mass of the different elements and use their subscripts to get the mass of 1 mole of iron oxide. Fe is 55.845, and multiply that by 2. Then add oxygen is 15.999, and multiply that one by 3. The result is 159.687. That's how many grams are in 1 mole of iron oxide. The canceling of the labels looks like this. The label remaining is grams. On the calculator, we can multiply together these two numbers. The answer is 3.27 grams. I rounded to have 3 significant figures because the first measurement in the calculation has 3 significant figures. Question B, how many moles is 64.0 grams of O2? This is just the reverse of question A. This time we're going to begin with grams and convert it into moles using dimensional analysis. Write down the given quantity, including the label, multiply, draw the fraction line, grams on the bottom so that it cross-cancels the original label of grams, and on the top, 1 mole of O2. Using the periodic table, we can figure out how many grams are in 1 mole of O2. Oxygen is 15.999 and times that by 2. The result is 31.998. These labels cancel out. The label remaining is moles. And by the setup of this calculation, we can see we go 64.0 times 1 and then divide by 31.998. The result is 2.00 moles. Again, I retained 3 significant figures because the first number in our calculation has 3 significant figures.